Hello, STEM learners. So today I'm going to cover this problem where oil spills into the ocean in a circular pattern. So let's begin by just drawing an image of what this looks like. So you can think about as oil spills, it's going to slowly increase and it's going to move outwards in a circular form. And so we see that the radius increases at a constant rate of 5 meters every 10 minutes. So that means that dr over dt, so that is the rate at which radius is increasing, will be a constant 5 meters every 10 minutes. And then it says, well, how fast is the area of the spill increasing at the end of an hour? So how fast is the area of the spill increasing? So what do we know about the area of a circle? Well, area is equal to pi r squared. So if we're interested in how fast or the rate at which the area is changing, we will need to calculate the derivative. So to do this, we take the derivative of both sides and we apply the power in the chain rule. So dA over dt equals 2 pi r dr over dt, which you can see in the top right hand corner, we already have dr over dt. However, if you look at the answer choices, they're in the rate of meters squared per hour, while the dr over dt that we have is actually in meters per minute. So before we can even apply that rate, we're going to need to do a conversion. And so we can convert the rate to meters per hour by applying the fact that in 1 hour we have 60 minutes. And after we do this conversion, we would get dr over dt is equal to 30 meters per hour. And so that's great. We have dr over dt, but in order to calculate dA over dt, we also need r. And so we know that the problem is asking for the rate at the end of an hour. So if we know that dr over dt is 30 meters per hour, well then r after 1 hour is going to be equal to that rate, 30 meters per hour, times 1 hour. So we know that our r will be 30 meters. So you assume that the radius starts at 0 and then it's going to expand outwards, 5 meters every 10 minutes, which is 30 meters per hour. So after 1 hour, the radius will be at 30 meters. So great, now we have our radius. So now we can just plug in the values that we have. We can say dA over dt is equal to 2 pi times 30 meters times the rate, 30 meters per hour. And if we calculate this out in our calculator, we will get 180 pi meters squared per hour, which is one of the answer choices. So that is the end. Hope you found this helpful, and I hope you have a great time learning.